Okay, so let's get started for the second part of this tutorial. So we'll go back to the visualization we've just created. So if you were here during the first part, we've built this shot map. We basically displayed all the events available in datasets along with their location, and it was a bit difficult to explore. So we've added interaction, filters by types of events, by players, but the combinations of events and players were actually quite important. So unless you try all those combinations to find something interesting, it's quite difficult to achieve. A way to actually visualize all those combinations of data attributes is to use what's called small multiples. So it's a very popular visualization technique that basically separates the duplicates and separate the visualizations into small miniatures, and in a way that each visualization is actually a filtered version of the main one. So you can filter by attribute, you can filter by time. And in our case, we're going to create those filter by players, and we will highlight some important events like the shots, the successful shots. And in order to characterize all the events from one player, along with specific ones that are important for soccer, so namely the shots. So small multiples have been used quite a lot, especially in basketballs, where you have different types of shots. And on the left, you can see that you have the jump shots during a game from the first half to the end, and as well as the layups, the dunks, and all the types of shots. And as you can see, the distribution is in a way that jump shots are very, very frequent. And the others, they are less frequent, and they eventually vary during during games, as some are more or less risky. How to implement the the small multiples with our visualization? So we're going to start another plot here. It's basically going to use most of the parameters from the previous one. So we're going to just copy and paste. And Observable has a very nice small multiples feature. It's called a facet visualization. I'm going to show you the documentation from this for this feature. So the facet is, as I said, is the duplication of the visualization based on attribute values. So here we have scatter plots that are duplicated by, in this case, that's based on the attribute series. So we're going to use this facet method. We're going to add to this chart. We're going to use our data set, which is called which is the data with we're going to use the data set, and we're going to use some facets for specific attributes. So what we want to do is we want us to have as many facets as player. So we want to split by the number of players. But the way it's going to work is we're going to have to set coordinates for each of those facets. And that's not the coordinates. It's not the type of information we have in the data set. So we're going to have to create the coordinates ourselves. And the way it works is quite simple. We're going to create some rows and columns, rows of, let's say, 5 players, and columns of as many we can fill. So that means we need to create first index of an index of player. So each player should have a number from 0 to probably 22 or a bit more. So here I'm going to create an index. So I need to add an attribute here called player. How we're going to call that? We're going to call that player index, which is going to be just the position of the player, this player. And we're going to take the position of the name of the player. Okay. So if we look at the I put type name was player name. Okay. Okay. So now we have players with index. So basically, our index are arbitrary. We just need a number, a unique number for players. And so as an X, we're going to use so this player index. And it's going to be the rows. But the player index goes probably up to 22, 23, but we only want value from 0 to 5. So we're going to do in the modulo 5. And now we want to have rows. And as many rows as we have filled with, as we are able to fill with players. So it's going to be number of players, the players index divided by 5. Okay. So we also need to add another mark called the frame. So it's gonna be around the players. It's a bit messy at the moment. I'm gonna remove the background. Okay. Okay. So I have my my data. Since I did a division and it has floating results, so I need to run the result. Okay. So now I have all my facets. The problem is that it's still filtered by players and by events. So I'm going to remove that. Okay. So now I have faceted charts. I'm going to call, so I'm going to put back the image. So the image, again, is a bit problematic. So because the coordinate system has changed, so I'm just going to copy and paste some adaptation of these coordinates, of those coordinates. Okay. So now I have the correct background, have one player per frame. So what do I need now? I need to color by, I'm going to add some color scheme. And I'm going to color by team name. So I'm going to fill. Okay. So I have two colors. I have a feeling the data don't spread as much as they should. I'm gonna change a bit of the parameters. Okay, yeah. So now they fit correctly. So again, this coordinate system is really important, and it's usually lots of time to spend to find the right parameters of both the background image and the chart dimension. So now I have my two teams. I'm gonna add the players' names because it's an important information to understand what we're looking at. So I'm gonna add a new mark here, dot text that takes the data and the text value would be the player name. Okay. Oh, sorry, I forgot something. So we don't have the player name. Do we have this? And then no, we should have the player name. I'm gonna have a problem of coordinate. Okay, so now with the player names, and we can see at the events distribution. And what I really like with those types of charts is you immediately grasp the player's role. You can grasp goalkeepers, midfielders, attackers. Some players don't have that many events, most likely because they got into the game not at the beginning, but during the game. So we have this nice charts. What I think might be a good addition is some more background information, because we have filter each chart, but what I like with filtering is to keep the context that we remove, but with some with a low opacity, so it gives some information but doesn't disturb too much the filter data. So how to add those information? So we're gonna use the same encoding. So we're gonna plot circles. We're gonna plot the full data set, and we're just gonna add small circles, like with a radius of 1 and of color, and with light gray as a color. And here it is. So now we have a nice, I think, small multiple chart. We have highlighted events that are for each players. We've kept some context, both the background field and the other events. And now the last addition is to add the goals. So if you remember correctly, there has been 3 goals during the game, 2 for Sweden and 1 for England. So how to add the goal? So goals are not actually an event. Goals are shots that were successful. So we need to go back to our data set. So we need to get another attribute from the events. So the attribute now is from the event. So we need to get into this, so the data set has when a shot occurs has a shot attribute. So we need to check if this attribute exists. See if it doesn't exist, then we don't put anything. And if it exists, then we get the outcome name. Okay. So we start that in our shot outcome. And here it is. So now we have a new attribute that exists if a shot outcome exists as well. So we now plot this shot. So shot is an event, not just plotted the same way we plotted the other data sets. And so we're going to plot a dot on the data. So it's actually the same type of mapping. They will be plotted as a red dot. So they will be visible. We're going to highlight them with a big radius. And what we haven't put yet is a filter. So the filter will be on elements that have shot outcome, which is a goal. Okay. So I'm going to double check what written. So we have plotted the data. We have applied a filter where shot outcome is a goal, and with X, Y, red, so it should be good. I'm going to double check. So unless there are not that many shots, so we need to look carefully. So they are not there. So there were probably there's probably something wrong with the way we extracted the shots from the data set. So we go back to the data here to the data. So shot outcome. Yeah. Okay, here we are. So now we have the shots outcomes that have led to a goal. So indeed, we have Jakobson and Aslanik who scored. So if I remember correctly, Aslani and Jakobson score for Sweden. And we have a goal for England from Kirby. And we can double check, it's indeed Kirby. So here we have this, what I think is a nice way of redesigning the shot maps. We have used space that preserves the spatial dimension. We have kept a good aspect ratio. So all the fields, they look like soccer fields. They are not distorted. We cannot re-distort them. And we have kept the background events distribution, filtered out and highlighted the events related to each player, so we can get an idea of the player's spatial activity, and highlighted important information for soccer, which are goals. And this way, we've created the layers. We have a very important information, highly visible, those red dots, but and progressively we can get some context. It's important to keep this context. Otherwise, if we had only represented the shots, we would have gotten this, basically the statistics, right? And the statistics, they exist for some reason. They are implemented everywhere, but they don't give a lot of background information. Why I think those kind of charts, they give a bit more of information, even though one would argue that the sequences of events that lead to a shot might actually be also of interest. So we'll get to this sequential approach to visualization. So we have this Lido application. I have it open on my desktop, so feel free to ask any question anytime. And I will try to monitor my second screen to answer the question. So now the last part of the tutorial, the coding of tracking data visualization. So tracking data is the data we get from analyzing the frame-by-frame position of players. Here's a short sequence of soccer. So I'm going to still use soccer data for to illustrate this tutorial. So what we're looking at Firmino, who passed to Mane, sorry, and Mane scored. So Mane is gonna score, and here is Firmino. Firmino passed the ball and Mane scored. Okay. So this is a very short sequence of a soccer game. Soccer game usually are 90 minutes. Here it's just a handful of seconds, but still, with tracking data, it's already lots of data. So it's an interesting sequence. So we started with from this sequence to do the analysis. And one of the interesting part of the analysis we want to know is if you look at Firmino, he actually does give the pass to Mane, which might not actually be the easiest thing to do, because if you look at on his right, you have Salah, who is also a good scorer, and Salah might have more space than Mane. So this is actually what we're going to do. We're going to do some space analysis of this sequence to eventually understand what were the characteristics of spatial occupations of the players before Firmino passed the ball. So for that, we are going to use an open data set from last row, which is available on GitHub. As you're going to see, the data set has less information than the previous one. Especially we don't have events. We actually don't have metadata. So here we just have positions of players during a short segment of a game that led to a goal. We have multiple games, and this is the structure of the data set. So it's a very, very simple data set, but still we're going to show you that we can do some interesting visualization. So we're going to do the same process, and I'm going to use the same notebook. I'm going to load the data. So it's a CSV file, so I'm going to load a CSV file. So I'm going to create another section. And I'm going to load, so I'm going to call it row2 d3.csv. And I'm going to auto type it immediately. Okay. So we have 75,000 positions, so which is a lot. So this is why we're gonna have to filter out some information. So let's see what we can filter out. So we can plot, we can visualize all the data as a table. Okay, so here we can see we have that we have multiple games. So I'm gonna just take one game we are interested in, and I'm gonna create another data set. And the game is Liverpool against Newcastle. Okay, so now I only have 3,000 positions, so which is more manageable. I have I'm going to show that as a table as well. Okay, so I have frames, which is the time code of the data set, and positions. I have offsets data. I have some other things, but I'm going to focus just on the frame and the position. So what do we do? Well, let's just plot the data. We have position, even though we don't have event. We can just plot and see what's going to happen. So this is plot. I'm going to create my marks. which is an array of dots. And here I've got 2 x, y. What did I miss? Oh, this was okay. So now I have my my tracking data. As you can see, it's relatively dense, continuous, and I can really get a sense of the dynamics of the game. This is what is interesting with tracking data. Usually, if you have a short segment, you just plot it and you get some good idea of the context of the action. So we have this we have those trajectories. We can add some color by team. Okay. What's interesting is we have this red team, which actually is the ball. So the ball has its own team. It's team 0. So it's nice. We have the ball, and we can really see the what are the trajectories. So here we have Mané, we have Firmino. Okay, so now we are gonna try to add some dynamics to this chart. So first, we need to add some background. Again, I'm gonna copy and paste the coordinate system for the charts and for the background image. It's gonna save us some time. Okay, so we have this. We still have those trajectories. Trajectory of the ball in red. What the trajectories don't really capture is the speed and the interaction between the players at a given moment of time. So we're just going to add a filter by time and animate this filter. So we're going to animate this chart. So in D3 there is in Observable Notebook, sorry, there is a nice widget. It's called a scrubber. So I'm just imported it here, and scrubber basically gives you the possibility to. So I'm going to define the time. A scrubber gives you the possibility to animate a time interval. So I need to know what this time interval is. As I said, the time is the frame number. So we need to find the time extents. So what was the beginning and the end of the time interval? So time extent for D3 extents. So data. Okay, so now I have my time extent, and I'm gonna give it to the scrubber. So he's gonna animate over a time interval, which I'm gonna create as a range of length, the upper bound of my time interval. Okay, so now I have this nice widget that's gonna play automatically for a given value of frame between 0 and 147. And now I just need to filter my charts based on this frame value. And here it is. I have an animation of the game. And as you can see, the Firmino passed the ball to Mané, and the goalkeeper goes out of his goal, drops the ball, and then Mané is gonna come back to score the goal. So this animation is I think is very effective. So it's a bit slow because I have other visualizations running in this notebook, but it's really nice, and I think it's really nice way to especially when you've seen the video to analyze the game. So there are still some improvements to make. The first one, we're going to make what I think it could be a small addition, but a nice way to also understand the encoding is to add to encode the ball differently and to encode it as an image, because we've encoded the background, but why not encoding the ball as a ball? So we're gonna load the ball, and I'm gonna create the data set the same way I've created it for the background field. So I'm gonna here just add. I'm gonna add the ball and have soccer ball. Okay. So I've added the soccer ball, but the soccer ball is not gonna be static. It's gonna be actually dynamic. So I'm gonna get the position of the ball, which is the position of the player from team 0 at a given time. And the URL will be so we have the ball. The ball is animated based on the time. Oh, it's not the team. It's actually the player that's 0. And it's not. So we have the team. So we have a filter here. Filter is on the frame and on the player X. Oh, yeah, sorry. X and Y are dynamic now. And so we have the player. So I'm gonna double check if the ball is player 0. Okay, it should be player 0. I was using the wrong, but okay, now it's good. And I'm gonna put the ball at the very end of the rendering. Okay, so now we have the ball. This was a very quick addition, but I think that really helps and makes the charts a bit more engaging. So still, if you remember, what we were supposed to analyze was the space occupation. Because here one might think that Salah had more space and should be able to have more freedom and less pressure on the defense than Mane. So how can we analyze this space? And we're going to use what's called some space occupation model, so a very simple one for this tutorial, which is the Voronoi. Basically, we're going to create partitions based on the closest regions, the closest space to players. We're going to talk about some improved version of this model a bit later, because it's not perfect, but at least it's very simple to implement. And hopefully, observable notebooks have, and the D3 toolkit has a very, very simple way to create Voronoi partitions. So here is the API. So the Voronois are considered as marks. So we just add Voronoi partitions as we create rectangles, dots. So I'm just going to copy and paste. We could actually just create, we could also create the Delaunay, which is the connections of the closest of the adjacent regions, adjacent Voronoi regions, and we could also create some hulls. Hulls might be interesting to use to group the defense or the attacks and see if they are aligned or have a particular shape. So I'm gonna use the Voronoi mark here. So here we have our image, and I'm gonna put it as a background. And I'm just gonna need to adapt this code. I'm gonna use my data set with X, Y, and the field by team. I'm gonna remove this pattern. Okay. So I've used the whole data set, which is not what I should do. And here we are. So now we have nice, what I think is a nice space occupation visualization. So each color, each dot is still a player, and the color and the cell around the player is the space it is the closest to compared to other players. What actually is here is a bit problematic is the ball is considered as a player. So let's just remove the ball. So here d data frame equals t, and d dot player is not equal to 0. Okay, so now the ball is not part of the space analysis. And here we have the story again. We have Mane is gonna pass the ball. So Salah is on his right here. So one might think Salah has space because there is just one defender, while Mane actually had some space when Firmino wanted to before Firmino passed the ball. But then the more Firmino went, the more Mane went running for the ball, the more the space is shrinking. Okay, until he gets the ball and he has very, very little space for himself. When I say little, I'm actually looking at the space in front of him. We're going to talk a little bit after. The space behind players are not very relevant. Still, the Voronoi partitions takes it into account as a space that the player controls, but it's not very relevant. So here, Mane, here the goal catches the ball, And then Mane actually had some space here, as you can see, to kick the ball and score. Okay. So so the reason why I think Firmino passed the ball is that Mane had some space when he hit, but at the end Mane was lucky because the goal actually had more space and just dropped the ball, and then so Mane could score. So that's the story we can tell with this visualization. So we look again at it. So we are close to completion of this second part. I've completed all the code demos. So the code is available online. It's you can use the notebooks I've written to reproduce or load the different data sets. What if you want to go further for sports visualization and analysis? So there are, of course, different directions. You could just make some tiny improvements over the visualizations we've made. Like the space occupation models, that's actually something we've improved a couple of years ago for these very same examples where we use the different versions of the pitch control. So the pitch control was introduced by Luc Born in 2018, and we've made different versions a bit after. Another opportunity to improve the visualizations, I think, is to take into account the perspective. What we have actually designed in terms of visualization is a kind of bird's eye view of the game. This bird's eye view is not actually the way we experience games. It's actually just a way to do it because charts usually are seen from above, where all the space is where all the elements in space are seen from the same direction. I mean, at least they are seen with a bird's eye view. And so that's what we reuse to draw the charts. But if you want to actually communicate your results and your analysis, it will make more sense to draw using the perspective of the camera. This is actually not that complex in terms of geometry. It's just homography matrix to calculate. I mean, to identify and then to calculate. So. As you can see, so you need to know what are the basically what's where are the corners of your pitch, and you just need to find those coordinates in your image, and with some matrix multiplications you can convert each pixels of the image to the bird's eye view, but you can also do the opposite. You can convert the bird's eye view to the perspective view. So it is not that complex in terms of, again, programming and geometry. But what's complex is actually to identify this matrix, this homography matrix. So basically the projections of the field in the camera. You need some annotation tools that are not necessarily easy to make. So we actually made one. There is the link here, and I can show you a quick demo. So basically, it's a way to let you annotate a pitch. So here I'm gonna annotate the pitch. So this is I'm getting my camera perspective coordinates. And here you see the result. You can see the pitch from above. Yeah, I need to make some adjustments. So as you can see, it's actually not very easy to find the right the corner of the pitch. It might be partial, there might be something hiding. Okay, so I get some sort of a pitch. And if first thing I can do when I've achieved that is I can get sort of from above view of the pitch. I can use that as a background image for my charts, which is a bit more contextual than just a black and white pitch. But what I can also do is I can now draw visualizations. So here it's you can look at the code. It's like canvas drawing mainly, and here I've redrawn. So it's not an interesting visualization. It's the T-sort matrix, and I've redrawn it on the field. So here I could draw my shot distribution chart, my space occupation chart in here. And as you can see, I can even have some interaction. And it will definitely add more context. Two issues with that is you are drawing over an image. So that means you are drawing over the players. So you might probably do some background removal first and then draw your visualization and add the players at the end. And the other problem is cameras are really not static; they usually move. So what I've done here took me a couple of minutes to get it right. You have to do it for each frame because the camera moves. Okay. So this might be doable for a couple of frames, but definitely not for a video. This is why we need to use some motion tracking tools from computer vision. Okay, so this is the end of this tutorial, and I'm happy to take any question. I'm not seeing any question in the Slido, but I'm gonna wait a couple of minutes, see if there is any question. I haven't talked about future opportunities of data displays. What's interesting is at the moment, there are lots of new rules regulating sport events. And one of them in basketball is interesting. They might be able to put some OLED, some light displays on the ground, which interesting way to include some live visualization, as long as you have the live tracking data at the same time. And in swimming, they're gonna add some tracking, some wearable technology to track the swimmers. It might start in 2023, so quite soon. So here again, new data opportunities for real-time tracking and eventually real-time visualization. I've also added a slide on sports venues and journals in case you want to get to know what are the recent advances for sports visualizations. Of course, the best way is to go on Thursday, sorry, to the sports visualization track. I've seen a question. So thank you for your question. So what the question is, what do you think is the simplest sport to visualize? That's a very good question. I'm gonna try to think for a couple of seconds. So that's a very good question. I don't think I have an answer for that. I would say if the question is about the sports in itself, it's really difficult to judge sports. Sports can get into like a whole level of difficulties based on for many reasons. And I cannot really compare sports. I don't know all of them. But I think the question is more if you want to get started to sports visualization and what would be the simplest data sets to use. And of course, it will lead you to specific sports. Again, I don't think I have an answer. Each data set they can get simple, but it's just because the scope is small. It's a goal, it's a season, it's just events. I think if you and even if it's simple to visualize, to plot, like you've seen, I've plotted like data in a couple of lines of code. That's the first step. Then next steps are usually more time consuming and require some knowledge of the field. Like for the Liverpool goal, it's we could talk for hours about it, and there's actually no ground truth of what led to a decision, unless of course you ask the player, but the player might say, okay, it was intuition, or it was different, some specific factors. It could have been tactics, could have been reflex, could have been just doing something different because he did the same. He was in the same situation before and he wanted to do something different. So it's very hard to plot data and conclude with a simple, with an obvious conclusions. It actually always raises more questions than it solves questions.